In this video, we'll cover an essential component of dplyr, the pipe. The R code used in this video is available on the Learning Management System. You should download it now if you'd like to follow along. By the end of this video, you should understand what the pipe is, how you can use the pipe in data wrangling, and how the pipe can improve the transparency of your workflow. So recall, the tidyverse includes a language for data wrangling called dplyr. It's designed with readability and ease of use in mind. A central component of dplyr is a new R operator called the pipe. So what is this pipe, and how are we going to use it? You can think of physical pipes in the real world as something that connects one thing to another. Stuff goes in one end of a pipe and comes out the other. On top of that, you connect lots of pipes together to move stuff around. Pipes in dplyr do much the same thing. They connect data and operations in R. The left-hand side of the pipe feeds information to whatever is on the right-hand side. You can chain many pipes together to make complex operations. Importantly, R's pipe syntax makes code easy to read and understand. In R, the pipe is denoted by this sequence of symbols here: a percent sign, a greater than sign, and another percent sign. The object on the left-hand side of the pipe is used as the input for the object on the right-hand side of the pipe. If you have multiple pipes in an R statement, it's going to start at the very left, read through, and work all the way to the right, one step at a time. Pipes are R operators. Like the other operators you're familiar with in R, if you end a line with a pipe, R will continue reading the next line and treat it as part of the same statement. I'm going to demonstrate using the pipe, but first I'm going to teach you a new R command. Before we start using the pipe, let's take a look at this new R command. It's part of the tidyverse, so you'll have to load the tidyverse before you start using it. This new command is str_c. I would call it string C. And what it does is it takes two different pieces of text and mashes them together into a single string. So here I have an example where I have string C of hello and world. What R will do is take these two separate string arguments and return a single string with that text mashed together. I'll run that code now. And what you see is it's taken those separate strings hello and world and returned a single string hello world. I'm going to use the string C function to demonstrate how the pipe works because I think it's relatively straightforward. So you can use the pipe with the string C function. In this little bit of sample R code that I have at the bottom of this slide, what I do is I take the string hello and I pipe it to the string C function with an additional argument world. How is R going to process this? The way the pipe works, it takes whatever the result of the expression on the left-hand side of the pipe is and makes it the first argument of the function on the right-hand side. So in this case, the string hello is the result of the left-hand side. R is going to take that and make it the first argument of the string C function and shift everything else to the right one, which is identical to typing out string C with the arguments hello and world. Let's try that out in R. So I'll type out that text that I had before, hello, followed by the pipe. Since the pipe is an operator, I can put in a new line, and then I'll enter that function string C with world as the only argument. I can run that, and you see I got what I got before, where hello and world are mashed together in a single string. So you can think about a more complicated example where you string three things together using two pipes. So in this case, I have the string hello. I'm going to pipe that to the string C function with world as an argument, and then I'm going to pipe that to the string C function with today as an argument. How is R going to process this? It's going to start at the very left end of the pipe, take the result of the first expression, which is just the string hello, and make that the first argument of that first string C function on the second line. That would be equivalent to typing this, but then R is going to evaluate that first expression, which returns hello world mashed together. It will then take that result and place it as the first argument of that second string C function before the word today. Thinking back to what we started with, that would be like writing out this really complicated expression here, where hello world was resulting from the first string C function, and that is nested inside the next string C function. Looking at this piece of R code, is it really easy to see what's going on here? This is the motivation behind R pipes. The fact is, everything you can do with pipes in R, you can do other ways. But R pipes make things easier, particularly complex tasks. They also make your code substantially easier to read because they organize your thought process into single, discrete steps, one for each line. On top of that, tibbles were designed to explicitly work with pipes, and the tidyverse was designed with tibbles in mind. This is an entire ecosystem that is going to make your coding more transparent. So in summary, pipes are designed to make your code easier to understand. The way you're going to use them is to place one operation on each line You'll indent your operations. RStudio does this automatically for you. And you're going to split up long commands across lines. Following this process will make your code easier to read and easier for people who are reading it to understand it.